Hello and welcome everyone to VMware Explore 2024. My name is Pete Keeler. I'm a part of the product team here at Broadcom. Joining me today, Mr. Duncan Epping.
Hey, my name is Duncan Epping, Chief Technologist. I'm not that technical as you can see. Not sure how the switch works, but we'll figure it out.
Indeed. So we're going to talk a little bit about the vSAN Express Storage Architecture. Today we're going to dive into a few different elements, why it's so important for all of you and why it's so important for us as well. And we're going to show you a little bit about how it works and some of the new and interesting things that we've been introducing within the past year. So of course, for the standard disclaimer, there are and will be certainly some things that we talk about that there's not necessarily a guarantee that will be delivered. So just the standard disclaimer there. So first of all, what is the vSAN Express Storage Architecture? This is essentially our next generation storage architecture that we debuted about 2 years ago today, somewhere right around there. This was built exclusively to run on next generation hardware. By that I mean NVMe storage devices, really fast networking, computationally dense servers so that you could exploit all of the capabilities within those hosts. Now, this is really meant for powering the workloads that you not only have for today, but for the future as well. And we've really focused on making sure that this could scale with the needs of your business. Now, it comes in a couple of forms, and really just in terms of a deployment option, you can have an aggregated vSAN HCI cluster, which aggregates the compute resources with the storage resources, as you sort of know and love. But of course, we've also introduced vSAN Max, which is our fully disaggregated storage architecture. Think of it a bit like a centralized shared storage solution for your vSphere clusters. Now, what you choose between those two, both of them are powered by vSAN ESA, what you choose is really up to you. The foundation is very much the same. When we think about the Express Storage Architecture, though, when we think about what it is, it's really a new way to process and store the data in a really efficient way, in a really fast way as well. We do this through a few different ways. One is we have a fast and efficient data path, completely revamped to account for some of these really fast storage devices. We also have an underlying data structure to make sure that we can store that data in a highly scalable way. So really for the past 18 months or so, we've really focused on how much faster and how much more efficient vSAN ESA is over, what we had in the past, that original storage architecture. But for this presentation, and we're certainly going to go over a few really interesting demos, we're going to focus a little bit on what new capabilities we can offer within ESA. I think that's one of the powers that we have within this new architecture is we can do things that we couldn't offer you in the past with the older architecture.
Yeah, and before we do so, it's probably good by a show of hands to understand if the audience is already using vSAN. So by show of hands, who's already using vSAN? That's almost every single person in the room. So are there any people already using vSAN ESA at this point in time? That's actually quite a big number, so that's good. At least we can start diving into some of the intrinsic details of vSAN ESA, and we'll also highlight some of the changes or compared to OSA for those who are not using ESA just yet.
Indeed, and we recognized too as well, because we had different hardware requirements, we knew that it was going to be a little bit of a slow on-ramp as you refreshed your hardware within your data center, but there was tremendous opportunity here. And with the flexibility that we offer you, we can say, here now you have a single solution that you can deploy in an aggregated vSAN HCI cluster, where you are aggregating the compute and storage in a single cluster, or you can have a fully disaggregated way. Now, which one should you choose? It really is up to you. You can run them empower your VMware Cloud Foundation environment using one, the other, or a combination of both. So before we get into some of the new features and the new capabilities, let's just review a few interesting aspects of the Express Storage architecture. What makes it so unique? One of the key elements behind the Express Storage architecture was our new log structured file system. Now, the goal of this log structured file system was to ingest writes as quickly as it can so that then it can prepare the data to be written in the most space-efficient way possible. So what happens here is as incoming writes are occurring from a VM, we ingest this into our log structured file system, which is a construct that is based off of a single object. So we have multiple log structured file systems sprinkled across the data store. This will ingest those writes really quickly and prepare them so that they can be written as a fully aligned full stripe write. That's why we can offer the ability to write the data in a highly space efficient way using RAID 5 or RAID 6 erasure coding, and there's no trade-off on performance.
Yeah, the other thing to probably point out, Pete, here in this particular case, when we talk about efficient writes, one of the reasons we're also doing that is for the flash devices that you guys will be consuming. I think it's something that people tend to skip over because people don't like to talk about most of the hardware components when it comes to this stack. But all of the newer flash devices that you will see today, they're all optimized for a particular block size. So that's why we made these changes to ESA specifically to cater for those devices as well, to ensure that you're not burning through those devices in an extremely fast fashion.
Indeed, indeed. And that's one of the things that we've seen, and we're accounting for even the newer devices that haven't come out yet. We want to make sure that this architecture has been aligned for those storage devices. Now, writing data certainly is one matter, and sometimes for storage systems, that's the most complex side of it. But there is another aspect of storing data, is eventually you do need to read the data. And this is an overlooked aspect of many storage systems, but to be able to read the data in a highly scalable way is very difficult. If you think about storing a massive amount of data, you need to understand and have metadata to understand where that data is at in order to fetch it. And when we're thinking about petabytes, multiple petabytes, that becomes very difficult. So let's sort of walk through and see what the anatomy of a read looks like within the vSAN Express Storage architecture. So for an initial read would be sent from the guest, and at this time it's going to check what we refer to as a DOM owner. This is sort of, it's a host that is sort of responsible for that given object. And from there, what it's going to do is that it's going to look into what we refer to as an IO bank. These are banks of memory that as the incoming writes come in, they get prepared for that fully aligned full stripe write. And it's going to see if the read is there. If it is, it satisfies the read and it's sent back to the guest. If not, it looks to a series of B trees. And these B trees are essentially a metadata structure that helps the system understand where the data payload is actually at. Now, from here, it's going to say, okay, now some of this metadata may point to data that's actually in memory still or on the actual storage devices. And it's going to assemble this metadata to then build up what we refer to as a lookup array. So then it fetches all this data, puts it in one package, and then fetches the actual payload itself and returns it to the guest. This is what makes the ability to have a highly scalable storage system so important. It's easy to make a storage system store a lot of data. That doesn't necessarily mean that it's going to be able to really fetch that data in a very fast way. Now, what's most important about all of this is that we understand the data path from the very beginning to the very end. And that's really important when we compare ourselves to other architectures, that you lose some of that intelligence the moment that it leaves the HBAs of the host. And you might think, well, why is that important in the first place? And actually, this sort of tees to the next demonstration here that we're going to look at.
Yeah, before we get started with the demonstration, has anyone actually experienced any performance problems with vSAN itself, by show of hands? It's only a few people, fortunately. So for those who actually have experienced any performance challenges, we've got a lot of tools in place to actually solve or try to solve those problems. Of course, within the vCenter UI, you see a lot of these graphs with all of these different types of metrics. But even in those cases, when you look at all of those different types of graphs, it can be very challenging to figure out at what particular layer the issue is occurring. So in order to solve those more complex problems, we actually have a solution in place, which is the I/O analyzer, the I/O trip analyzer. And the I/O trip analyzer basically allows you or enables you to look at what different layer or what different layers the issues are occurring from a latency perspective. So if you go to the Performance tab and you go to the I/O trip analyzer section in the Performance tab itself, you have the option to start an I/O trip analyzer section. Now, when we open up this particular section of the UI, as you can see, we can select if it needs to start now, if you want to schedule it. So if you, for instance, always have a problem at midnight, you can schedule this. You don't need to wait next to the host in order to use this. Now, for those who have already seen this, in the UI, one of the things that's actually different in this particular demo is that you can select multiple virtual machines. So if you have a particular service which consists of 5 virtual machines, starting with 8.0 Update 3, you can now actually monitor all of those virtual machines at the same time. So when you click Start, it's going to collect all of the data during the time that you've specified within the UI. So let's say you're collecting that for 10 minutes, and then after 10 minutes, when it has actually concluded the monitoring aspect of things, the data is going to show up in the UI itself, and you can inspect the results. Now, when you look at the results, the interesting thing here is the following. As you can see, we have a virtual machine name at the top and we have a virtual disk. And then when you look at the virtual disk itself, you can see all of the different components that are part of that disk. So these are all of the lower level vSAN constructs. Now, the nice thing here is of course, you can click to all of the different types of virtual machines that were part of that monitoring aspect. But it also shows you the latency on every single layer. So if you have networking latency, for instance, it's going to show up here. If you have disk latency, it's also going to show up here. With OSA, for instance, you will even see disk controller latency. Of course, with ESA, that doesn't apply. But all of these different types of information are available within the UI, and you can start troubleshooting and try to figure out what is actually causing that problem. And this will definitely help having that conversation with the networking team, for instance, because that's always the most challenging aspect, because they will definitely point typically to the storage. At least that's my experience as a former administrator. So that is the I/O trip analyzer that we have available. Now, when we talk about performance, there are a couple of other solutions as well where we increased performance immensely. If you look at vSAN, ESA specifically, I think one of the biggest enhancements that we introduced to the platform is the way that we're doing snapshots. Now, I'm guessing that every single person in the room actually has used snapshots in some shape or form. And my guess is that the majority of you have also seen performance challenges in the past, whether with VMFS or with OSA when it comes to snapshots, and especially when you create multiple snapshots. So that is something that we actually looked into and we wanted to change. Not just for vSAN or related versus OSA and ESA, but we also wanted to make sure that the way that we snapshot virtual machines is different than people have been doing traditionally with regular storage systems, right? If you snapshot a VMFS volume, that happens on the volume level, not on the virtual machine level, unless, of course, you're doing something with vVols. But I'm guessing the majority of you are not. So what we made sure with this particular enhancement is that we're not only capable of snapshotting on the VM level and snapshotting on a per disk level, but we also made sure that from a performance perspective, it performs way better than you've seen so far. So what I'm actually going to do in a couple of slides, actually show you what the performance difference is and how consistent that performance is for vSAN ESA specifically. And I need to be clear here, this is for vSAN ESA specifically. So the changes that we introduced do not apply to OSA. Now, the reason it does not apply to OSA is because we actually introduced various different mechanisms into the platform to achieve these enhancements. If you look at the UI here and you're, for instance, using 8.0 Update 2, some of the components you see in the UI are not part of the solution you're using today. So if you're using 8.0 Update 2 with ESA, you also have scalable snapshots, but not to the extent that we have available here. What we're actually showing in this particular case is that we've actually introduced a new mechanism that also enables you to create deep snapshots. And when we talk about deep snapshots, we're actually talking all the way up to 200 snapshots per virtual machine, which is significant. You can imagine that if you would do something on OSA, probably around snapshot 7 or 8, you will see the performance start degrading. And that's something that doesn't happen with ESA. The other thing I want to point out here before I actually go to the demo is that it actually shows a global namespace on this particular diagram. And this global namespace is actually new. And this is something that we use for what we call the data protection appliance, where the logic actually resides to create these snapshots. And that global namespace is part of the vSAN data store and collects all of the metadata of all of the various machines you're snapshotting. And the reason we actually collect it on the data store itself is in case anything happens to the virtual appliance, we can reinstall that appliance and still look at the different snapshots that we've created. So we've created kind of like a fault tolerance solution for that. And of course, it's being protected by the vSAN fault tolerance mechanism as well. Now, I want to show you what those snapshots look like and what the result is of the improvements that we've implemented in the platform itself. So what we have here is my physical lab. And what I've actually done in my physical lab is I've deployed HCI Bench. And I've just picking a random workload to start here just to show you what the performance looks like. Now, this is not a fully supported vSAN ESA environment, so the performance is not at the level that it probably will be in your production environment, but it's just to show you what happens when you start creating snapshots. So at this point in time, I'm actually starting the workload, and of course, when you start the workload, it's going to start producing IOs. So as you can see, 45,000 IOPS, you see the throughput and the latency, but we'll get back to that. So now that we've got the workload running, of course, what we're going to do is we're going to create a snapshot. I'm not going to create just one snapshot. I'm actually going to create multiple snapshots. I'm not going to show the creation of 5 or 6 snapshots in this demo because that would be quite boring. But the interesting aspect here is the following. If you look at the graph itself, you can see that the graph is flat. Although the performance slightly decreased, so it went from 45,000 IOPS down to 44.5, it more or less remained flat, and so did the latency. The interesting thing here is the following, is that it will remain flat whether it's for the first snapshot or snapshot 199. So the performance is not going to change across the board. The other interesting aspect here is that if you delete all of the different snapshots, normally you would see a significant performance drop because we need to start copying data from one object to the other object. And that is something that doesn't occur with vSAN ESA either because we are not creating additional files or are creating additional objects. The big difference between the snapshot mechanism that we've implemented with vSAN ESA compared to OSA is that the snapshot actually happens on the metadata level. So we're making a copy of the metadata structure instead of creating a new object or a new file to store the IOs that you're doing. So that's the big difference between that platform, and these changes result in a much better performance. Now, of course, that by itself is already very valuable, and I think a lot of customers will appreciate it to create local snapshots. But of course, the idea behind this concept is to provide you a mechanism that will allow you at some point in time to actually offload that data as well. And that's where vSAN data protection, in combination with some of the other services that we have available, of course, comes into play. Now, I've got another demo in a couple of slides that I want to show you, and I'm just going to talk through some of the capabilities that I will be demonstrating in this demo, because I realize that probably for the majority of you, what I'll be showing is going to be brand new. When it comes to vSAN itself, I think one of the interesting capabilities where we introduced with the vSAN data protection platform is we enable you with this new mechanism to start creating protection groups. Now, I need to be clear here, this particular protection group that I talk about is not a consistency group. So we have 20 virtual machines part of this protection group. They will be snapshotted around the same time, but not necessarily exactly at the same time. So it's not a consistency group, just to be. Now, of course, with these protection groups, when you start protecting these virtual machines, you can start doing interesting things. So you could create one snapshot per hour, then one per week, or one per year, and retain them for an X amount of time, depending on the amount of storage, of course, you have available. And of course, you can start creating many of these different types of protection groups. And as stated up on the screen, any given virtual machine can be part of up to 3 different protection groups. Now, of course, these different protection groups can have different schedules as well, and I will also show that in the demo what that looks like. Now, the other thing which I think is always interesting, or at least useful to talk about, is some of these maximum numbers, because it's one of those questions that we always tend to get. I've already mentioned it. When it comes to the vSAN ESA snapshots, you can go 200 snapshots deep. And from a performance perspective, as I just shown in the demo, that is not going to make a difference. The other one, which is probably interesting for those who have a large number of virtual machines, you can protect all the way up to 3,000 virtual machines at this stage per vCenter server. So that is something to take into consideration if you have a larger number of virtual machines as well. And then, of course, there's also things around the minimum snapshot interval and, of course, the minimum retention period. So that is also something to take into consideration when you start creating these snapshots. Now, let's start looking into the platform itself, because it's probably more interesting than just talking about it. So I created this demo again on my physical environment, and this, of course, is a vSAN ESA environment. Now, what I've done with this particular vSAN ESA environment is I deployed the vSAN Data Protection Appliance, which allows us to start creating things like these protection groups. And as you can see, it also presents this new user interface, and that's all part of that data protection appliance. So you need to install and configure that first before you actually see this particular screen. Now, when you do so, of course, you can see how many virtual machines are protected, how much data is being stored, what the capacity is of the snapshots that are being stored, and of course, when you've created protection groups, you also see these in the UI. Now, besides those protection groups, you can also see all of the virtual machines which are protected, and I will actually show you what you can do with the snapshots later on as well. Now, let's go back to the protection group section, and I'll actually show you what it looks like when you create a protection group. So in this particular case, I'm going to create a new protection group, and I'm going to protect a couple of virtual machines. And there are a couple of interesting options here. The first option that I'm going to take is immutability. This basically means that if you enable this, that no one can delete the protection group itself or can make changes to the protection group. So be careful when you use this functionality. The other thing which is interesting here is the way that you can select virtual machines. Of course, you can manually select virtual machines, but that's going to be very tedious. In this particular case, I'm actually selecting the virtual machines by providing the asterisk, my initials, and then those virtual machines that belong to me are automatically selected. After the VMs have been selected, of course, I can start creating my snapshot schedule, and that can be anything you would like it to be. In this particular case, I'm using one of the traditional snapshot schedules of 1 per day, and 1 per week, and 1 per year. So that is something that we tend to see a lot, of course. After the protection group has been created, it's going to take, in my case, because I selected 1 per hour to start off with, an X amount of time before the first snapshot is going to be created. But when I go to the protection group itself, I can already start protecting all of the virtual machines that are part of it by manually taking a snapshot, which is then going to be the first snapshot. And when that first snapshot has been created, it's going to create it, of course, on all of the virtual machines that were part of that protection group. And as you can see, it instantly shows you the information about those snapshots as well. It shows you how many virtual machines, how many snapshots, when the first one was created and when the last one was created. When you go to the virtual machine itself, it also shows you some of that information. And when you click on those virtual machines, of course, you also get additional information about the snapshot itself. Now, as I said, you can edit the protection group, but only when it's not in immutability mode. So that is typically what I would recommend customers to do first. Play around with it when it's not immutable. When you've created a snapshot schedule and you want to pause it temporarily for whatever reason, if you're doing maintenance, of course, you can do so. And of course, you can also delete the protection group if you would like to do so. Now, if you have the snapshots on a virtual machine, not only will you see those snapshots within that data protection interface, but you can also see the snapshots on the per virtual machine level. In this particular case, the virtual machine has multiple protection groups. So it's actually showing snapshots of all of those different protection groups as well, and you can restore those snapshots. Now, the one thing I want to point out here is I actually clicked restore, and if you restore a snapshot, it is going to power off your virtual machine. So just be aware of that, because it's going to roll back to the particular point in time. So it powers off the virtual machine, which also means that when it rolls back, you need to power it down to actually start doing things to that particular virtual machine. So as it has rolled back, as you can see, the interesting thing is that all of the different snapshots that were created, both before as well as after, are still available. So if you want to go back to that last point in time, you still have the ability to do so. The other thing which I think is interesting when it comes to this particular concept is that we also have the ability to clone a virtual machine. So this is different than restoring, because when I clone a virtual machine, it's not powering off the virtual machine. It's actually creating a second instance of that virtual machine. Now, this is also where you need to be very careful, because when it creates a second instance and you power it on, guess what? If you have a hard-coded IP address, you may have two virtual machines with the same IP address on the network. So that is something to take into consideration. You may want to disable the network card. The other thing that I probably should have pointed out, and actually highlighted it here, is that it's not just a regular clone, it's a linked clone. So it literally takes a second for that linked clone to be instantiated and you can start using that platform. You can imagine that this is something that in the future could be very useful for developers or application owners in your team who just want to test something against a particular build or whatever it ends up being. Now, as I said, of course, you can also delete protection groups, and when you delete a protection group, you actually have the option to also delete all of the snapshots associated with that protection group or not. So you can even retain those snapshots. The other thing which I think is interesting is that we also have the option to restore virtual machines which have been deleted. So if an administrator, for whatever reason, deletes a virtual machine which shouldn't have been deleted, the platform actually allows you to retrieve those virtual machines through this option. So you can actually go back in time. And of course, we're using that metadata mechanism for that. All of the information is stored within that database. And that basically allows us to restore those virtual machines back to the platform itself. Now, when you start restoring virtual machines, or in this particular case, when you've got the virtual machines restored, of course, like I said, all of the snapshots are also available. That's what I'm showing here. I have to refresh the screen because we just re-imported the virtual machines and we were basically reassociating the snapshots to that given virtual machine. But you have all of those snapshots instantly available within the interface on top of that. Now, the last thing I would like to show is some of the information that is available the last thing I wanted to show is the deletion of the protection group itself. As I said, you can delete the snapshot with it. I do want to make sure that to inform people that there is no rollback in this particular case. So if you delete those snapshots, they are gone. If you delete the virtual machines after that, you will not be able to recover from that particular scenario. So be very careful with deleting the snapshots. As I mentioned, when it comes to immutability mode, in this particular case, I had one protection group which is in immutability mode. As you can see, there is no option to delete this or edit this or make any changes in any form. So again, if you want to use immutability mode, which I can understand why people want to do it, make sure you make a very conscious decision in terms of how you use that particular option, because you're not capable at this point in time to make any changes. And I know at the end of the session, someone is going to ask me, are you planning on making any changes in the future to the platform that will potentially allow us to make changes to port group or to protection groups which are in immutability mode? And yes, we are considering that, but it doesn't exist today, and I'm not even sure if it will exist in the next major version. So just be aware of the fact. Let me hand it over back to Pete, who's going to talk about vSAN Max.
Yeah, absolutely. And I think that was a great representation in so many different ways of, we were able to harness a technology like vSAN ESA snapshots and translate it into something that you could just set it and forget it. We all have, sort of dreamed of those snapshots behaving in that sort of way where you just let them go and the system will figure out how long they should be kept, and it will manage it. And there's even safety mechanisms built in. So if you have a high change rate of data and you're taking a lot of snapshots, it's going to pause those snapshot schedules if you exceed a certain threshold within the cluster as far as capacity is concerned. So a lot of nice little features built in there. So next up, I want to just touch on a little bit about what ESA provides in terms of disaggregated storage, and that's in the form of vSAN Max. vSAN Max is essentially our fully disaggregated storage solution that provides centralized storage for vSphere clusters. And like I mentioned earlier, the choice is yours, whether you want to have vSAN ESA powered systems deployed in a fully aggregated vSAN HCI cluster, that's great. If you want to do it in a disaggregated way, that's great as well. Now, you may be running through some thoughts of thinking, well, which one is the best for me? Well, it's really going to fully depend on your arrangement. If you have had the need to have, let's say, your compute environment may scale out at a rate that is different than your storage arrangement, that may be well suited for something like vSAN Max, where those are independent. If you have a dedicated storage team, that the storage team wants to own that storage, then something like vSAN Max may be a good option for you. If you have some portion of your organization that wants their workloads, maybe they paid for it on a separate line item within their budget toward their workloads being fully independent, then something like vSAN HCI works out really well because these storage resources are treated as a resource, as an exclusive resource of the cluster. So then you can kind of separate out noisy neighbors and all that sort of thing. Regardless of what you choose though, it's all powered by ESA. It's going to be managed in the exact same way. So you don't have to really learn anything new there. And it's, of course, fully integrated into the hypervisor. Now, one of the questions we get fairly often is, well, what do you use to actually connect to that vSAN data store within vSAN Max? Are you using iSCSI? Are you using NFS? And will it run over Fibre Channel? And all those sorts of things. The answer is we use our own protocol that rides on top of TCP. And it's known as RDT, and it is specifically built for a fully distributed storage system. It's what we've been using in a vSAN HCI cluster since its inception. And this allows us for an extremely lightweight build up and tear down of various sessions as we understand where the data is living at and where we need to fetch it from. But one of the things that it allows us to do is it allows us to not be beholden to some of the technical debt that comes with these other protocols, such as iSCSI and NFS, that were intended to do something very different. This allows us to say, okay, you as a user can prescribe storage policies or manage this in the very same way because it is seen and managed in the very same way within the system itself. Now, you might think, okay, well, we just described it as this distributed scale-out centralized storage system. I have a storage array. Why don't I just stay with that? One of the primary differences between what vSAN Max offers and a traditional modular storage array is the architecture itself. So when we think about a known storage array, a modular storage array, you usually have a head unit with a couple of controllers, some shelves with some storage devices within that. And of course, you'll use your favorite protocol to connect to that storage array from your vSphere host. Well, as the traffic from the vSphere hosts leave the HBAs of the host, they go through that storage controller, either an active sort of passive arrangement or pseudo active arrangement, really depends on the manufacturer. But what we are doing is essentially funneling that data through a given storage controller. And for an IT administrator, or a storage administrator, that's always presented a bit of a problem. Like, well, how much power do I need on that storage controller? Which model should I get? And this is a real challenge, especially as this arrangement grows, where you have additional vSphere clusters, vSphere hosts, because you have additional workloads. So this fundamentally has been a real challenge historically with this architecture. You're also sharing those very same shared resources, RAM, buffering devices, CPU processing within that head unit. With vSAN, it's different. And with vSAN Max, it's very different, where you have each and every host that makes up that vSAN Max cluster provides CPU, memory, network interfaces, and storage devices. And that means that for each and every host that you add, you're going to add performance at a linear scalability, capacity, and so forth.
Yeah, and one of the things I also want to point out here, because I think it's very interesting, we had a discussion with a customer earlier this week, and they said, we are never ever going to do vSAN ESA or vSAN in general. At the end of the discussion, one of the interesting things that happened is when we started talking about vSAN Max, he said that he particularly liked vSAN Max because of the fact that it actually reminded him of a storage array. And the key reason that he was very interested in adopting vSAN Max after the discussion was the fact that it was something that could completely stand on its own. So you could have your own vCenter server, which could have a different AD associated with it, and then it could have a single cluster. So it would be a completely separate entity that they would manage, and they could have a different team managing those resources on top of that. So that was one of the reasons he was actually interested in vSAN Max, which I found very interesting because at the start of the meeting, he said he was never ever going to adopt vSAN in general. So.
Yeah, indeed. Yeah, we've heard that repeated. And one of the things when we introduced vSAN Max later last year, some of the early feedback was, wow, this looks really interesting. I'm not quite sure if I need multiple petabytes of storage, because that's how we really shared it to the general public. Well, after we heard a lot of feedback about that, we sort of went back to the drawing board and said, maybe there's an opportunity here to meet some of those needs for you on smaller environments or more modest sized environments where you like the idea, and maybe you might be an existing vSAN HCI customer and you want to have that in your environment. So we've been able to lower the minimum requirements through additional validation and testing and so forth. So you can start really small if you wish. And in fact, let's roll through a scenario here where we have a small environment. Let's say it's a legacy 3-tier architecture, and you have your storage array, and you're interested in introducing vSAN Max in this environment. So you could start out with as few as 4 hosts and build up that vSAN Max cluster. It could be as small as 80 terabytes and certainly go up from there. And you can mount that single data store to those other environments. Now, you may say, okay, well, we just added more resources, so hey, let's add some more vSphere clusters and so forth. And remember, those vSphere clusters, they can mount the vSAN Max cluster. They can just be regular vSphere clusters. They don't need to comply with any special VCG for vSAN or anything. So here you have this additional storage provided by vSAN Max, and you go, hey, this is great. This is working out pretty well. This is where the incremental scalability really works out, because then you can say, now I'm going to add a few more hosts, and it's going to expand that single data store so that then you immediately have additional storage capacity and additional storage performance all within that single data store. And then from there, you can continue to grow. So that's, I think, a really good example of how you could start small if you're interested in an environment like this. Now, most certainly, we've had some changes in licensing and how you actually procure VMware Cloud Foundation. And I want to just touch on this a little bit because there's a little bit of confusion about how vSAN is a part of that package. And I think this is going to sort of hopefully help illustrate how when you buy VCF, you have integrated storage that you are entitled to already. It's part of the solution. So let's step through what might this look like. So here we have a 16-host vSphere cluster. This has 512 VCF cores. You have a 1 terabyte entitlement of vSAN for every core that you license. So in this particular case, you could say, wow, I have 512 tibibytes that I could use. That could be in a vSAN HCI cluster. Or if you say, no, I want to keep these vSphere or this vSphere cluster just fine, and I want to spin up a vSAN Max cluster. So let's say you have a 6-host vSAN Max cluster, and that has 240 VCF cores that would be comprised of that. But when you combine that, you say, wow, I have over 750 tibibytes of entitled storage that I can use. It's available to me right now. So here is an opportunity to see you're taking advantage of software that you already own. Then from that point on, you can see if this is a good strategy for you in the future, then you can sort of integrate this into your procurement process. So I think it's a good representation of the ability to say, I've been letting this hypervisor manage my compute and my memory for years, if not decades. Maybe it can manage my storage as well. And that's really what this is all about. Occasionally, we get some questions about networking as it relates to, well, just vSAN in general, as well as vSAN Max. Now, just with any type of storage system, and let's remind ourselves that vSAN is a fully distributed storage system. Each and every host makes up that storage system, and the network itself is the storage fabric. So we obviously have some requirements around networking, and we generally recommend for vSAN Max starting at 25 gig for a vSAN Max cluster. The very entry-level vSAN Max ready node will accept 10 gig, but let's move on to 25 and faster. But you might be thinking, well, wait a minute, I'm not sure if I have any 25 or 100 gig switches in my arrangement. You don't have to rip and replace your entire environment. You can start with a single rack and just say, this rack, you buy a pair of 25 or 100 gig switches, set them top of rack, build up the vSAN Max cluster, and then that's going to satisfy the need of the vSAN Max cluster. And then you can use for your vSphere clusters your existing network infrastructure and sort of introduce faster networking when it makes most sense.
Yeah, and the other thing to point out here is, of course, from a networking perspective, what Pete mentioned about 10 gig, this is also something that applies to ESA in general. Yesterday, I think I had 4 discussions with customers separately. They were all complaining about the fact that we require 25 gig networking or higher, but vSAN ESA has been supporting 10 gig networks for the past year or so. So if you're one of those customers who are challenged when it comes to switching, of course, with vSAN ESA, we can still do 10 gig networks, but we have to say that depending on the amount of or capacity that you're introducing and your performance expectations, you may not be meeting the minimum requirements from a networking perspective. So take that into consideration.
All right, so that pretty much wraps it up for this session. But as you can see, we're really excited not only about where vSAN ESA is, but where we're going. You've maybe heard some interesting announcements about what we're working with for vSAN in general, vSAN ESA in general. So with that, I want to thank everyone for attending.
Awesome, and hopefully we'll see you next year.
Yeah.
Thanks.
Yeah.